We are recording now. Oh, just as my dog. Okay. You get the quiz open.
Now this is LO9 homework quiz, right?
9, yeah.
Question 1, it says, which one of the following best defines the notion of the p-value of a...
1 second. Sorry, I'm still trying to get it open.
Yeah, me too. Just a sec.
Yeah, I opened my applet and it kicked me out. I had to go back in.
Oh, no. What'd you say?
Repeat the first question. Myra?
Yes, I can't hear you guys very well.
Okay. None of us?
Can you hear us now?
Let me try. What question are we?
We haven't started yet. We're on question number 1 or 2 or 3.
LO9 homework quiz. Unless I'm on the wrong quiz.
No, you're on the right quiz.
You're good. How did the test go for everyone?
Good.
Good. Okay, is it open for everyone?
Yes.
Okay. Number 3. Which hypothesis involves equality? The null, the alternative, or the true?
I don't have that.
For number 3?
I'm in the LO9 homework quiz. You know?
Oh, you need to be, sorry, in the group meeting quiz. You open the homework that's due on Saturday.
Okay, let me get back to where we need to go.
Sorry, right lesson, wrong quiz.
Week 6, right?
9. Oh, I don't know what week, but lesson 9.
It's week 5, lesson 9.
Here we go. LO9 group meeting quiz.
Yeah.
Okay. Okay. Question
Number
3.
3. Which hypothesis involves equality? That would be null, right?
Yep, null
Yes.
hypothesis.
Okay. Number 4. Number 4. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true?
The null.
The null. Does everybody agree?
Mm-hmm.
Okay. Suppose the null hypothesis is mu equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test? So that would be the second option.
The third option, the not equal to 10.
It could be either or,
Oh, yeah, sorry.
the two-tailed.
I'm reading it wrong. My notes, anyways. Oh, and then if it's the greater than or equal, or greater than or less than, it's the one-tailed.
Yeah, if it's greater than or less than, it's 1, and then if it's the not equal to, because it can be either side, it can be greater than or less than, so it's two-tailed.
Okay, gotcha.
And then the next question, which of the following represents an alternative hypothesis for a left-tailed test?
That would be less than.
Correct.
Okay.
I believe so.
And then number 7, which of the following represents the alternative hypothesis for a right-tailed? So that would be number 2. Greater than.
Yep.
Okay. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Which relationship would result in failing to reject the null hypothesis?
Which relation would result to reject? So the p-value would have to be greater than alpha. I think it's the first one. Let me grab my notes.
It says here, if the p-value is more than the level of significance, we would fail to reject the null hypothesis.
So it's the first one, I believe.
Okay.
Yeah.
And then the next one, which relationship would result in rejecting the null hypothesis?
So it would be less, or it would
Less.
be, second one.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be an appropriate alternative hypothesis? So,
View number 3. The average claim is greater than 1,500 would be their alternative hypothesis. Alternative hypothesis, because they're saying that it's actually higher.
so they're saying it's higher, so then it would be 3, right?
Yep. You concur, Brian?
Sorry, I just grabbed my calculator.
I thought-
Oh, sorry, I'm at work. And let's see.
We're glad
Sorry.
we can meet.
Which of the following would be the appropriate alternative hypothesis?
Yeah, I mean, it started and everything is fine.
Yeah, it's greater than, so the average claim is greater. So the third one?
Yesterday after we jumped it, and then today it was off. So that's
Okay. Number 11, which of the following would be the appropriate null hypothesis? So it would be,
Equal to first one.
or
we take the boat
is
out.
it equal to, or is it not greater than?
It's equal because it's the high.
Or is
Because
it?
you always assume that the null hypothesis is true. Like that previous
Okay.
question.
Oh,
You keep getting crap till you go.
so it'd be number 1?
Yes.
Yeah.
Gotcha. Okay.
Yeah. No, question number 4. When computing the p-value, which hypothesis do you assume to be true? And that was the null hypothesis. So you always
Okay.
assume that it's equal to.
Okay, gotcha. The insurance company randomly selects n equals 40 claims and calculates a sample mean of x equals $1,650. The insurance company assumes the distribution of the sample mean is normal. Is that a good assumption?
Yes, because the n is over 30.
Yep, because it's a large enough
Okay.
sample size.
So number 1. What theorem or law justifies your answer to the previous question?
Law of large numbers.
Is that the law or is it central?
Is the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. Oh, wait. Yeah. And then the central limit theorem is. Oh, you're right. It is central limit. I apologize.
Okay.
I get those ones mixed up.
Yeah, me too. I was like, wait, I have to second guess myself. Which of the following is this test statistic as defined in this lesson?
The X bar.
Yeah. Does everybody agree with that?
Can you show me where you got that so I can comprehend that?
Just above in the information, but above question number 12, where it says the X bar equals 1650. When
Kind of the subject of the.
trying to determine if it's the statistics or the parameter, basically is what it's asking. But out of the information given, the X bar is the statistic because that's something that is.
Is it part of the mean?
Correct. Yeah.
Yeah, it's kind of the number that they give you that of like what was tested is the statistic, I guess.
Yeah.
So number 14 is X.
Yeah. The first one.
Oh, I thought it was C.
Is the Z?
Yeah, I thought. Okay, I just saw it somewhere.
You could be totally correct.
Yeah.
Let's look it up. Let's figure it out. Oh, you're right. It is the Z. The test statistic is Z. It's the Z score. You're right.
So what makes it that?
That's just sorry, we're not trying to find parameter or statistic. It's just that's the value. So in the textbook 4.2, the test statistic, so it says
X, it will be the sample mean.
says we need to determine how far the
C.
X bar is from the mean. Since we know that the standard deviation in this case, we can use the Z-score. We can use the Z-score to determine if X bar is far from the assumed value. This is called the test statistic. Where
Okay.
Z is the test statistic, X bar is the sample mean, and then the mu, whatever that is the population mean. So you're right. All right, it is Z. Thank you for that.
Okay, the next one. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals $144. What is the Z-score associated with this test?
Okay, so the formula would be to get a z-score would be n minus mu over standard deviation.
So, for this one, since we're dealing with a since we're dealing with a sample size of 36, it's the equation is 144 minus 150 over the standard deviation divided by the square root of 36.
144 minus 50.
Yeah, divided by 40 divided by square root of 36.
Okay.
Am I wrong in thinking that? You guys good?
That's what I
got negative 0.9.
0.9. Yeah.
Let me do that real quick, sorry. Yeah. Negative 0.89.
That's not what I got. Maybe I did it
Oh.
wrong because I didn't divide it. Okay.
You had negative 0.89? I wonder why mine's 9. I wonder why mine only gave me 0.9. I didn't round.
Oh, maybe that's what I did wrong. I rounded. Let me not round.
I got negative 0.9.
I probably, just because I rounded, is where I went wrong.
It does say round to 3 decimal places, though.
Well, if you don't round, I got the same thing. I got negative 0.9.
I know, but I'm just saying it wants 3 decimal places, so is that wrong? It's only 1 decimal place. I don't know.
I don't know.
Let's see
Are you
what our
tricking us?
z-score is here.
What is the p-value associated with these?
Okay. Are we ready for 16?
Yep.
No, I need the, so that it's going to be 0.900, right?
It's negative 0.9. I wouldn't add, I don't know. I'm not adding the 0, but
It
Yeah, I
says
don't know.
it says round to 3 decimal places.
When you put 0.9 into the applet, it puts 2 zeros on the end. I don't know. I don't know what he wants as far as that. We can put it either way. Either way you feel you want.
I'm gonna put the 2 zeros on and we'll see what happens.
Perfect.
okay. What is the p-value associated with the z-score from the previous question? P.
It's 0.3681.
184.
That's what I got. 0.184.
Then I guess I need your equation.
We're just putting the z-score into the applet is all we're doing.
Which way are you shading?
To the left, because
Okay,
our alternative hypothesis is asking is
because
the
it's
mean
negative.
less than 150. So whatever is less than our z-score, which would be to the left.
So 0.184.
0.184. Yep.
I shaded right, but left. Finally.
Okay. 17. What inference would you make about the null hypothesis for this problem? Need to read the question again.
0.05. Our p-value is greater than. So we would not reject.
So failed to reject. Let me read it again. Okay, yeah.
Question 17.
So it's reject or to reject?
And it's because of the answer we got because it's greater than,
Mhm.
Yep, because the p-value is greater than the
So it's just
alpha. So
it's failed to reject.
Yeah.
we failed to reject.
So what is your conclusion for this problem? Would it be 1? Wait.
Yeah, we have insufficient evidence.
what is the population? Do we know? We only know that the sales receipts and the deviation.
Or would it be 3? The true population is like the, I don't know how to explain it. It's like saying like the true mean of the population, I guess, not like. Does that make sense? I don't know how to.
It's hard to
I have a hard time explaining it.
Yeah.
Like just take out like the true mean. You don't have to say population it. So like the true mean is 150. You can use it without it. So would it be 3 because they're trying to prove that it's has decreased.
Yeah, so we have insufficient evidence to state that it's less than 150. So we're still assuming that our null hypothesis is true. So
True.
So it would be number 3.
Okay.
I think. That's what I think. I shouldn't say that
That's what I think as well.
with super confidence because we'll probably get it wrong. But
there are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? So that's type 1.
yeah, type 1.
A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true?
So by decreasing the alpha, we increase the probability of getting a type 2 error. So the second one?
Okay.
Because when the probability of one goes up, the other goes down. So by decreasing alpha, wait, hold on, by decreasing the alpha score, by decreasing it, you're increasing the probability that the p-value will be larger than. No, that's right. Yeah, I think it's the second one. I think it's probably type 2 error will increase. I don't know. What do you guys think?
I have no idea. Well, it would. Isn't a level of significance in a type 1, isn't it with type 1?
Say that again.
So like when it says like level of significance of alpha, isn't that a type 1 error?
Correct. That is a type 1 error. Yep. Alpha is equal to the probability of a type 1 error. So if you're decreasing the probability, you're decreasing alpha, you're decreasing the probability of it being a type 1 error. So if that's going down, then you're increasing the probability of having a type 2 error.
Oh, okay, gotcha. Okay, so it would be B.
I think so.
Right, yeah, okay. That makes sense. Oh, okay, I see it. Oh, this is a lot, okay. Do you guys understand that, or do you agree with that?
I just need to, I've read the information 3 times. It's Greek to me. I have to go back and look at it.
So did you watch the videos?
I watched all the videos.
So on the video, when it says a type 1 and type 2 errors, and it gives you that like little chart that says like conclusion, you know, like the do not reject the null hypothesis or reject the whole, and it kind of teaches you how to like define a type 1 error.
Mm-hmm.
Right underneath that next slide, he goes over a bunch of rules. That's what we're looking at right now.
All right, so in the textbook, it says here, if the A value, the probability of committing a type 1 error, is very small, the probability of committing a type 2 error will be large. So, yeah, so just like what I was saying. So if the probability, if the A value or the
Level of significance.
yeah, is low, then your probability of having a type 2 increases. What's that, Myra?
It's going in.
Does that make sense? That's in section 4.5 of the textbook of lesson 9. Lesson 9, section 4.5.
Thank you.
Yeah.
Okay. So number 21, if alpha equals 0.05, compute the probability of committing a type 1 error. So
What is the formula for computing this?
I'm actually not sure on this question.
okay.
If committing a type 1 error is undesirable, oh,
Excuse me.
bless you.
I don't understand what this question's asking. Oh. Wait. Wouldn't it just be 0.05? Isn't that the probability of committing a type 1 error is equal to A is equal to the probability?
Oh. Oh yeah, because it's I don't know.
We should choose alpha to be some smaller number so that the probability of committing a type 1 error is low. The most common value for alpha is alpha equals 0.05. This is equal to 120. So when the null hypothesis is true, there's a 1 in 20 chance that it will be rejected at the 0.05 level of significant. Other common choices for alpha are 0.1 and 0.01. But as far as compute the probability, is that meaning we have to go into the probability applet and put that in? Because probability means area, okay? So if we put it in our applet, but it's not a z-score, but if we put so I'm not knowing how to compute this.
You were right, Brian.
It's 0.05.
I submitted it and it was 0.05. You're right.
Oh, okay. Okay, I was like, I don't see there could be any other way.
Yeah, we got a 100, so everything is right. Don't put the 0, 0 at the end of yours, Wanda.
Oh, on that one?
Yeah, because I didn't and I got a 100, so.
Then I won't.
Yeah.
That question is kind of confusing.
Yeah, it is. I was like, what? Quickest way to find out if that's true.
I didn't realize that was the last question.
Yeah. Almost there. Okay.
We did get
I think I'm
100.
going to go over that one again. Yay.
That was a confusing,
Question.
confusing chapter.
It was a tricky one.
Yeah. I did it while I was on my break at work, so I didn't get enough time to really think about it. So I need to go over it again. But
Yeah.
okay. We'll meet again on Monday.
On Monday.
Okay. Okay, see you
Sorry,
then.
that's perfect. I just got a call. Thanks, guys.
Oh, good luck. Bye.
Bye.